And here are some of the challenges, and I think this is the last slide, and we can open it up afterwards, that I think are areas that we need to do better or dramatically better to make the Internet of Things really pervasive and allow us to fill up the new fabs that we're going to build when we're out there. The first one is intuitive and simple interfaces. I often put this as when you have your refrigerator and toaster connected, you do not want to have to program the toaster to be able to put it on your network and get some information for it, nor do you want to have a truck roll. So have the engineer come out with the refrigerator to install it and have a very complex pad where he's pressing 14 different keys, right, in 23 different combinations to make it work. It has to be foolproof connectivity and provisioning. I have to say the industry does this in incredibly lousy ways. The only thing I've been impressed with is Sonos. If you've ever seen the sound systems, I have them. It's a sound bar and subwoofers and a total surround sound system that you download onto your iPad. It's a setup procedure. The setup procedure is very simple. You basically push one button on each device and it introduces it. You tune the system. What used to take a truck roll with the engineer coming out doing perfect tuning, and today you can do it with the one push button. But the vast majority of things are not like that. Harden applications that can go indefinitely without crashing. You know, the beauty of consumer things is that you can do control alternate delete. You can push the button on the phone when it doesn't work. You don't want to be doing control alternate delete on your car in the middle of the freeway because it needs to be rebooted, right? You do not want to have your meter that you have to crawl through the basement and find a little button to push it because you have to restart it. That French company Wavecom that I ran that did machine to machine, it was really built on having an incredibly hardened protocol stack so that you didn't have the problems that you had in the standard GSM phones. On the other hand, I do not think the vast majority of applications are near hard enough. And like our guys who do security says, anytime you have software, you have a problem, right? It's beauty because it goes really, really quickly, but you also almost guarantee to have an issue. So that is going to continue to be a problem. And the last is probably the most important. And other than the slide on the percentage of reuse, it's something that I would encourage us all as engineers or managers to think about, is that cost is not only going to be critical, it can be the only thing for some applications. And the cost is going to have to be taken out by architectural changes where you completely rethink the system. So even though we're a memory company and a cryptographic core company and we do binary pixels, the biggest group that we're hiring is hardware and software architects that can go in and work with companies like Facebook, like Google, the people on those previous charts in that ecosystem, and talk to them. And it's really funny, some of the brilliant hardware and software architects, that, just to give you a real proof point, we were in a meeting with a very large and successful company on this slide that I won't tell you who it was. And we sent with them some of our memory architects and some of our most brilliant process technology experts and where the industry is going and what they're doing. Really, really deep guys that have been doing this far longer than I have. So the hardware architect comes out of the meeting and talks to me and he says, we sat there for 3.5 hours with the customer, right? We both heard, myself and the guy who does the micron and molecules, we both heard exactly the same thing. We even went to the restroom together, so he wasn't left alone at all with the customer. And yet, I came out and heard something completely different than he did about where the industry was going and what was relevant in technology. So being able to understand how to, at the highest level of system architecture, make changes that allows the economics to flow through is going to be incredibly important. If you have a 5-cent sensor, like some of the things that we're doing in our computational imaging group, but you have to attach it to a 20-cent module to make it or $20 module to make it communicate, it just doesn't make sense. Okay. So here's the last thing, and I'll get off the stage, and I think it's for you the most important. If I was to look at anything going forward, I would go back to that expanding bubble or the expanding arrow chart, think about the Internet of Things, and think how India could become a global leader in it. There is no reason to not, because sometimes when you have not been more advanced in some technologies, you get to eliminate the past and think forward much more greatly than the others do. I think you've all seen that with wireless technology. I don't have a landline. I will not have a landline. My children, right, who are in teenagers now, wouldn't even know what a landline is. And I remember the first landline in our house, it was actually a party line where you picked it up and sometimes somebody else was on the phone because they didn't have it. We were in the suburbs, not in the city, and they didn't have it. So there's a huge difference, and sometimes being last makes you first. So I hope that this is something that you will take near and dear to your heart and find something in it to make a lot of money for your companies and yourselves and your investors. Thank you. Yeah, happy to do some Q&A if there are any. I didn't torture the economics too much, I told you. Yes?
It's a very interesting concept you introduced about margin stacking. And the way I see it, you are also emphasizing a lot of semiconductor IP creation and reuse. But you are essentially sandwiched between the overall margin that the products can command and what you can actually get as a semiconductor IP. So why would you propose that as a value add?
So it's an absolutely excellent question. And by way of example, this French company that I ran, we did a lot of work with automotive. And so we did baseband chipsets and the protocol stacks. I mean, that was really, we were a semiconductor company. But when you went to the automotive groups, they couldn't take the chips and do anything with them, right? You would go to the customer and say, here's a chip, and here's a great protocol stack, and you go and do it. But because they're not wireless experts, they couldn't, so you had to make a module. And then in this module, right, unfortunately, they had to put it into a box, a little box that would do SOS connections with the airbags went off in the car. And then that box they had to put with a navigation system because that was the way the system went. And then that navigation system went into the car, and then the car went out and you sold it through the retail channel. So on every step along the way, somebody was out there, right, trying to find a way to increase the 50% along a gross margin on every step. So it was a very expensive and painful process like you just described. So the way that we found as a necessity to work it is quite candidly to disaggregate that value chain and to go upstream to the people who are making architectural decisions and try to drive from where they're moving backwards and ensure that the model actually worked. So sometimes we do that in partnership with the people in the value chain and say, look, either we find a way to solve this or we can't, or we would just not enter it. And part of the reason, they don't have this slide up, but the slide that I had for the ecosystem is to do just that. We are actually spending in Rambus a lot of time talking to what would be our customers' customers and understanding the architectural needs that they have and ensuring that the IP that we create actually solves the problems that they're at. And what it does fundamentally is put more bargaining power in you, the IP provider, because there are not 14 different groups that are all doing the same thing. So it is a huge problem. The only way I've been able to find to solve it is basically go to the end, near the end of the value chain and have that end customer who owns the channel drive backwards into the value chain and help sort out the problem so that you have a rational business. And quite candidly, what normally happens is companies understand that if they attempt to margin stack, to take your product, double the value of it, and pass it on for adding no economic value add, they can't do it.
Okay, thank you.
So I have a couple of questions. You talked about IoT a lot, right? Can you give some perspective? Means certainly if you look at the more developed countries where a lot of such devices exist and it makes a lot of sense to have basically them talking to each other all the time. But in the context of a country like India, how basically at the current stage or maybe in next 5 years, IoT can be a practically useful tool where masses don't have basically that many gadgets which can talk to each other, probably one mobile phone, 90% of the people don't have fridge and those kind of the things, right? So in context of India, can you give some perspective about this IoT?
I think it's a very good question. I had great experiences, and I've actually used this, I think, with some of you when I've described, in South Africa. So in a previous company I ran in South Africa, it was a large proportion of the business, and they were doing machine-to-machine type applications. And it was funny because when I first joined the company, I said, wow, this country has 15% of the revenue, of our revenue. Why does this country have so much? And I visited the company regularly. Every 2 months or 3 months I was going there because it was very important. And there was a set of breakthroughs that they went through. And the team, I asked some of the businesses, they had a little forum like this one, how did you invent so many of these novel implementations? And they said, well, it was out of need. So during the time when there was apartheid, we didn't get a lot of support from all of the Western countries. So we were basically cut off. We were in the middle of a war with Angola, and so we had to make our own helicopters, our own weapons, and it was a very difficult time. The war with Angola stopped, and we had 350,000 engineers that went out of work because they were working in defense military complex. And we decided that we had to create a startup culture because either it was that or we couldn't eat. So they started a lot of things, and they got together and they said, well, what do we know better than anybody else? And they said, well, 2 things. Communication technology, number 1, and number 2, how to make things really cheap, because we don't have a choice, because there's no other way to do it, right? The cost, the disposable income for our population is rather small. So they started inventing an entire set of communications technologies and tools that were deployed around, say, to use phones in villages that they didn't have them. So I think that some of the disadvantages you have as you're coming up can be advantages if you think about it from an economic standpoint. I was with one of the professors at one of your renowned universities here, and we were talking about looking at disease blood analyzers, things like that, that could be done in a very inexpensive and cheap way through silicon technology. And it was basically, the concept was, how do we create something that's disposable in nature? We have some of our sensors that could be used in this sense, and deployed in a way knowing that in most of the villages, the people don't have the internet, they don't have a way to go other than a cell phone. We don't have huge ability to set up mobile medical centers, and he came up, and it looks like there's a possibility to do very small mobile kits that are disposable that you could take to the villages. So that's a small Internet of Things, because it would be a small device. It would have maybe a Bluetooth chip on it and a small battery to a handset that would take the information and pass it back and do some analysis in the cloud. So there are a variety of ways, I think, if you try to take what is appearance as a disadvantage, look at it as an advantage and try to innovate around it. Because you will tend to come up through necessity with ideas that you won't get, let's say, in Silicon Valley, where we do not suffer from having too little money.